Hello everyone. This is a new live session on. Here we'll be discussing questions on BJT, that is a bipolar junction transistor. All right. So I hope you will enjoy this session because this is very important from the point of view of JEST. Okay. Because in JEST, questions from electronics come very easy, so you should be able to do that. So we'll be practicing some questions from BJT today, bipolar junction transistor. Okay, bipolar junction transistor. All right. Please let me know, is the voice clear and all. Okay, let's start. So first question I'll be giving you. I hope you have studied this chapter. So we will directly start with questions. Madam, consider the circuit. Mm, it's just a second. Okay, consider the circuit as shown in the figure. As shown in the figure, and find the find the Q point. Find the Q point of the fixed biased circuit. Fixed biased circuit. Okay, as biased circuit. Assume assume that ICBO is very less than IB. Okay, so the diagram is like this. It's the resistance here. This is 12 volt. This is 240 kilo ohm. This is a 1.2 kilo ohm. Okay, beta is 100, and it's grounded here, and this connects with this. Okay, so you have to find the Q point in the circuit. So if you know what is Q point, first of all, Q point, what is Q point? Q point means you have to find VCE and which one? VCE and IC. This is your Q point. You have to find. Okay, please try. Let's try this question. Yes, very good evening, Abhishek. Thank you for joining. Please try this question. Okay, how to solve this question now? See, in a BJT, in a BJT, suppose this is your, the circuit is usually like this. This is your IB, this is a RB, right? This is a V input here, and this is a IB. This is your collector current IC. This is your base current. This is your RC. That is your collector resistance. This is your VCC. This is your collector. This is your base. This is your emitter. Okay. This is your VBE here, and this is your VCE here. Okay. And this is your emitter, right? This is your emitter. So emitter current goes here, and this is your emitter resistance. So if we know this IC is going here, this IB is going here, so they are mixing up to give IE. So IE is equal to IB plus IC. Okay, I is equal to IB plus IC, and we have to write the equation from this side and once from this side. We'll use Kirchhoff's law like to write the equations, right? So I will start with VCC minus, because current is going through the resistance, minus ICRC. Okay, and here the voltage will be minus VCE, and here IE into IE RE. Okay, IE RE, that will be equal to how much? That will be 0, right? Because it's grounded here. And if this loop we consider, it will be VI minus IBRB minus IBRB. Okay, and here it will be VBE. Okay, minus VBE. Okay, minus IERE, that will be equal to 0. Did you understand? Did you get it? Okay, so if you see here in this diagram, our diagram, there is no emitter. Okay, so we can write the equation. Okay, we can write the equation from VCC from here. So I will write the equation. I hope you have drawn the diagram. Okay, okay. So I will write the equation here. VCC is equal to here ICRC. Okay, plus VCE. Like same kind of thing, VCC minus VCE minus ICRC is equal to 0. Okay, so I can just take it to that side. That will be VCC is equal to VCE plus ICRC. Is it all right? Is it all right? Okay, so I just wrote it here because there is no okay, so there is no emitter current here, emitter resistance, so we will do that. Okay, so could you please give me some tips for solving reasoning for MRFT examination? See, Sosmita's botany, this is here I'll be discussing physics only, so reasoning part I won't be discussing in this channel. So please you check out other channels where they will be discussing reasoning. Reasoning you have to, the thing is, if you have a particular, for example, the exam is 2 hours, right? So you have to divide your time according to that. And if the reasoning is suppose 10 questions for reasoning, so you should be giving only 15 to 20 minutes to that reasoning part. Okay, you should be doing it also very fast. Otherwise, it will take up your time and you won't be able to do the answers, your own topic answers, like your Smith's botany. So botany you won't be able to do like in time, and you will face problems at the end. You'll be thinking why I give up so much time. So just take 15 to 20 minutes. In that time, whatever possible, just do. There will be no negative marking. So please try to do it fast, and also try to do everything. Don't leave anything behind. Okay. Yeah. Okay, that would be it. Okay. So I was saying VCC is equal to VCE plus ICRs. Okay. Okay, now VCC. Okay, what I was doing. Then from other side, if I see from other side, I can write it here VI minus IBRB. Okay, minus IBRB here minus VB is equal to 0, right? Minus VBE is equal to 0. Okay, yeah. So from these two equations I can write IB is equal to what? Okay, VI in place of VI I can write VCC also. Okay, IB is equal to VCC minus VBE by RB. Can I write it from this equation? I can write it, right? Okay. Yeah, yeah. Thank you so much. Okay, you're welcome, and all the very best for tomorrow's exam. Okay, I hope you do well. Yeah. VCC minus VB by RB. So VCC is your how much it's given in the question or not? VCC, yeah. This is your 12 volt. It's given in the question. It's 12 volt. So see, because I can this diagram I can do it in another way. I can just remove these parts, right? I can do what? I can remove this part. I can take it to here, right? I can take that to here also. This 12 volt. I can take this to here, 12 volt. So this will be a VCC, isn't it? Right? Yeah. So this is a VCC. So now if you see, what was I doing? VCC minus VB by RB, right? So 12 minus VB is always 0.7, right? VB is always 0.7 divided by RB. So RB is your what? RB is also given. RB is also given here. If you see, this is your RB, isn't it? Because this is connected to this base part. This is connected to the collector part. So this is your RB. Okay, RB is your 240 kilo ohm. So 240. Okay, 240 kilo ohm. So I will get it as 11.3 divided by 240 kilo ohm. Okay. So if I divide it, I will get something like 47 microampere. Because this is kilo, so kilo will go. It will make milliampere. But if I do more calculations properly, it will give me 47 microampere. Is it all right? Okay. Yeah. So that will be 47 microampere. Now, IC. Okay, we know IC is beta IB plus 1 plus beta ICBO. Okay, this is your formula for IC. You have to remember this. And if IB is very greater than ICBO, then I can directly, IB is very greater than ICBO, I can directly write this only, because IB is very greater than ICBO, so I can just ignore this part. Okay, so that will be IC is equal to beta IB. Is it alright? IC is equal to beta IB. So if you see, beta is 100, so 100 into IB we got as 47 microampere. So 47 into microampere, that means 10 to the minus 6 ampere. So that will be 47 into 10 to the minus 4 ampere. So that will be 470 into 10, 4.7 into 10 to the minus 3 ampere. That means 4.7 milliampere, isn't it? So this is your 4.7 milliampere. This is your what? IC. Okay. This is your IC. Now what do I need? IC is gone. So we are asked in the question, what is the question? Question is Q point. Find the Q point. Q point means in a BJT, Q point means you have to find VCE and IC. Okay. Now we have found IC. How to calculate VCE? VCE is equal to VCC minus ICRC. We have written the equation in the beginning. Right. Like this, VCC plus VC. Like VCC is equal to this much. So VC is, I just take to this side. So VC is equal to VCC minus ICRC. So VCC is 12 minus 12 is given in the question, minus 4.7 is what we got into 1.2. Okay, so that will be it. So that will be 12 minus 5.64. That will be 6.36 volt. So this will be your VCE and this will be your IC. So that will be the answer. So this is the Q point. We are asked Q point, right? So Q point is what? Q point is VCE and IC. So that is 6.36, 4.3 volt, 4.7 milliamp. Okay. Yeah, very good. So that will be the answer. Please go through it and let me know if you understood or not. Okay, next question. We'll move to the next question. Okay. So here if you see in the diagram, we have this 15 volt. This is a 470 ohm. This is a 4 kilo ohm. Beta is a 200. Okay, this is 1 kilo ohm. Okay, so find the values of, consider the voltage divider bias circuit as shown in the figure, as shown in the figure. Find the values of IC and VCE. Okay, please try this question. This biasing is called voltage divider biasing. Please try. Please try this question. Quality of video low. Okay, just a second. Okay, just do this question. After it, I will try to sort it out in the next video. The quality I will try to sort out in the next video. See here, voltage divider bias. That means you have to find the voltage. How to find? See here, you have to find the voltage. How will you find this voltage into this resistance divided by this plus this? Okay, this is how you find. So 15 by 5, that is 3. So 3 volt is the voltage here. Okay, got it? Yeah. Now what is the like resistance? 4 into 1. These two are in parallel. 4 into 1 divided by 4 plus 1. 4 into 1 divided by 4 plus 1, that is 4 by 5 ohm. So this is 4 by 5 kilo ohm. Sorry. So 0.8 kilo ohm. So the circuit will kind of become, it's like this again. So this is the 15. Right. That will go like this only normally. This will become like this. Okay. And the resistance, the voltage we got will be here 3 volt, and the resistance will be 0.8 ohm, 0.8 kilo ohm. Okay, and everything will remain as it is, 15 volt. This is your 0.47 kilo ohm. Okay, we'll convert everything into kilo ohm. And this one is how much? This one is 220 ohm. Okay, sorry I didn't write it here. This is 220 ohm. That means 0.22 kilo ohm. Okay, so this is your now final diagram. So if you see, how will I get the? I just put the values now. 3 volt minus the current will be IB. Okay, 0.8 IB minus VBE minus IE into 0.22 is equal to 0, right? So VB is 0.7. So 3 minus 0.8 IB minus 0.7 minus 0.22 IE is equal to 0. Okay, is equal to 0. So IB you have to find, right? Okay. Now see, IE is what? IE. IE we can write as 1 plus beta 1 plus beta IB, right? So beta is how much? Beta is your 100. It's given, right? Beta is your 200. So put 200 here. That will be 201 IB. So in place of IE, just put 201. So 3 minus 0.7 is 2.3 minus 0.8 IB minus 0.22 into 201 IB is equal to 0. Okay. So just you have to solve it. So if you solve it, actually you will get it as IB is equal to 56 microampere. Okay. You will get it 56 microampere. Now IC is simply beta IB. So 200 into beta, that is 56 microampere. That will be, if you see, that will be 11.2 milliamp. Okay, you get it. Now what we need? We need this circuit. This circuit you can write 15 minus 0.47 into IC. IC is how much? Because this current here is IC, right? So IC is what? Here 11.2. So 11.2, then minus VCE. Okay, minus IE into 0.22 is equal to 0, right? So IE we know what? What is your IE? IE is again 1 plus beta IB. So 201 into IB. So we can put it here, 201 into IB. IB we know. So from there we can calculate what? VCE. Okay. I hope you understood. Yeah. So this is it. And yeah, I know the quality of the video is not that good today. Okay, I will try to sort it out in the next video. Alright. Yeah. Okay then, thank you very much. Thank you very much for watching. Thank you.